Hello, dear calculus students. Well, today we're taking a look at assignment 33, and this is the last of the new material before we start reviewing for the test. And I'd actually like to start today with a little bell work problem. Um, find the average rate of change on 1 to 2 for f of x equals x squared minus 3x. Okay? So pause the video, compute that average rate of change, show me that you're getting all this stuff that we're talking about. I can't wait. Okay, welcome back. So remember, we need f of 2 minus f of 1 over 2 minus 1 to find that average rate of change, because average rate of change is just the slope of the secant on that function between these 2 points. So f of 2 equals 2 squared minus 3 times 2, which is negative 2. And f of 1 is going to be 1 squared minus 3 times 1. 1 minus 3 is negative 2. So f of 2 minus f of 1 over 2 minus 1. Okay, so that's going to be plus 2 minus 2. That's 0. Huh, isn't that interesting? The average rate of change is 0. Well, let's think about this graphically for a moment. If we factor this, we get zeros at 0 and 3, and we have an up-pointing parabola. And so when we're finding the average rate of change between 1 and 2, we've got this, remember, line of symmetry at x equals 1.5. So these are the same y values. They're just being reflected across this axis. So it doesn't surprise me that the slope of the line connecting them is 0. Okay, so that's average rate of change. But wait, there's more. Hey, so I'd like to review the 3 limit definitions of the derivative. Without looking at your notes, can you write them down? You need to. You need to be able to do that by the time we have this test. Okay, so the first one, f prime of x, is the limit as h heads to 0 of f of x plus h minus f of x all over h. We also had 2 limit definitions of the derivative at a point. One of them was simply our general derivative, but at a specific point instead of at the general x. So we have a plus h minus f of a all over h. All right, we also had a second limit definition of the derivative at a point, and that was the limit as x approaches a of f of x minus f of a over x minus a. All right, so guess what? I want you to use this one. Please find f prime of 2 given f of x equals x squared minus 3x. I'd like to find f prime of 2, please, using f prime of a equals the limit as x approaches a of f of x minus f of a over x minus a. So pause the video, find f prime of 2 with this f of x using this limit definition of the derivative. Okay? All right, come back when you're ready to chat now. Hey, welcome back. So we need to find f of x. Oh, there it is. And we need to find f of a, and since our a is 2, we could really understand this as f prime of 2 equals the limit as x approaches 2 of f of x minus f of 2 over x minus 2. Okay, so what was f of 2? That was 4 minus 6, or negative 2. So then f prime of 2 will equal the limit as x approaches 2. Look, if you leave this out, it's average rate of change, not instantaneous rate of change. So I got to mark it wrong. Don't leave this out. Okay? Okay. So f of x is x squared minus 3x minus, what was f of 2? Negative 2. Okay? And that's all over x minus 2. Well, let's take this further and say the limit as x approaches 2 of x squared minus 3x plus 2 over x minus 2 will be the limit as x approaches 2, because I still can't do the direct substitution. I get 0 over 0 again. But this is factorable. X minus 2, x minus 1 over x minus 2. Hey, look at that. And now, once I've canceled those out, I don't have 0 over 0 anymore. I can just plug the 2 in there. 2 minus 1 is 1. So I know f prime of 2 equals 1, using that limit definition of the derivative. All right, now that we've used that limit definition of the derivative, let's find f prime of 2 using f prime of a equals the limit as h heads to 0 of f of a plus h minus f of a all over h. Okay, and I want you to use this limit definition of the derivative to find f prime of 2. Pause the video, go do that work. All right, so we know that f prime of 2, the slope at 2 on f of x, will be the limit as h heads to 0 of f of 2 plus h minus f of 2 all over h. Well, we found out that f of 2 was negative 2. Well, what about f of 2 plus h? Well, f of 2 plus h means I have to replace all the x's of f of x with f 2 plus h's. So 2 plus h squared minus 3 times 2 plus h. So I FOIL here, and I get 4 plus 4h plus h squared, and I distribute the negative 3 to each of these, minus 6 minus 3h. Is there anything I can tidy up? Sure, 4h minus 3h is 1h, and 4 minus 6 is negative 2. That's f of 2 plus h. So what do I need to do? I need to do f of 2 plus h minus f of 2. I need to take this and subtract negative 2 from it. Well, when I subtract here, minus 2 minus a minus 2, those cancel, and I'm just left with this on top. Okay, so now I've got f prime of 2 is the limit as h heads to 0 of h squared plus h all over h, right? Because f of 2 was this minus 2, f of 2 plus h was all this stuff. I subtracted them, and I was left with just here. And don't forget, it's all over h. Can I do direct substitution yet? Can I plug this value into all these h's? Not yet. I still get 0 over 0. So f prime of 2 is going to be the limit as h heads to 0 of, let's factor in h out, and then cancel. Now when I plug my 0 in for h, 0 plus 1 is 1. So f prime of 2 equals 1. There, we've done it a second way. Guess what? Now we need to do it a third way. So find f prime of 2 given f of x equals x squared minus 3x. And I'd like you to find f prime of x and then plug a 2 into your f prime of x. Remember, f prime of x is the limit as h heads to 0 of f of x plus h minus f of x all over h. Okie doke. Pause the video. Give it a go. Can't wait to see. Okay. Hey, welcome back. So f prime of x, then, is the limit as h heads to 0 of, what's f of x plus h? Well, that's x plus h squared minus 3 times x plus h, or x squared plus 2xh plus h squared Don't forget to distribute the negative, minus 3x minus 3h. Hey, you remember all that foiling you had to do from middle school on until last year? It was to get us comfortable enough so that we could do this quickly and not drop the negatives. Okay. Now, what am I supposed to do? I'm supposed to subtract f of x from that. F of x is x squared minus 3x. So x squared minus x squared, those cancel. Minus 3x minus 3x, those cancel. And I'll tell you something. If when you're using this difference quotient, all of f of x does not cancel out, then you've got a mistake. Because what happens every time is f of x always cancels out. So if f of x doesn't cancel out for some reason, you've got a mistake and you should go find it. Okay, so then 2xh plus h squared minus 3h. So let's go and say that f prime of x is the limit as h heads to 0 of this subtraction was 2xh plus h squared minus 3h all over h. That's where we are now once we found this and found this into the subtraction. Okay? Got a little smaller. So I can't do direct substitution yet or I get 0 over 0. So let's take an h out of everything. 2x plus h minus 3 over h. We can cancel those troublemakers out, and now we can plug the 0 in, and we get 2x minus 3. So f prime of x is 2x minus 3. This is a little slope machine. It will find the slope on this graph at any point I plug in for x. It's very handy. And I want to know f prime of 2, so I'm going to plug a 2 in for all those x's. And so I end up with 1. There we go. F of 2 equals 1, or f prime of 2 equals 1. So we've now done this 3 different ways. You need to be able to do this, these 3 different ways, and on your calculator. And, you know, I really want to say that when you see, for example, the limit as h heads to 0 of cosine x plus h minus cosine x all over h, I need you to say, oh, they want, they want the derivative of cosine x. That's what that's telling me. In fact, if I saw this, I would say, they want f prime of pi over 2 given f of x equals cosine x. In other words, they want the slope on cosine at x equals pi over 2. Okay? AP multiple choice, this is how it's going to show up. They're going to give you this thing and then ask you, what is that? They're not expecting you to evaluate this limit. They're expecting you to recognize what this is and then find the derivative using the shortcuts we'll be talking about in the next unit. Okay, but no shortcuts yet. We're going to do these long limit definitions of the derivative. Okay, so we know that f prime of 2 equals 1, and we know that f of x equals x squared minus 3x. Fabulous. Hey, I got one other question for you. Write the tangent line to f of x at x equals 2. Will you pause the video and try that? Come back if you need help or when you're ready to check your answer. Okay, so in order to write a tangent line, I need a point, and that's going to be f of 2. So that's 2 squared minus 3 times 2, or negative 2. 4 minus 6 is negative 2. I also need a slope, which we found using our limit definitions of the derivative. So then the tangent line is simply plugging in that point and slope. I don't have to do anything else. I can walk away right now. I recommend walking away right now because if you make a mistake moving this to the other side, or if you make a distributing mistake, you've lost your answer point. This earns the answer point. Please stop here. Okay, this is the tangent. Oh, but I didn't want the tangent. I wanted the normal. So what has to change here if I'm writing the equation of the normal? Well, we know the slope of the normal is the opposite reciprocal slope of the tangent. Well, the slope of the tangent at 2 was 1, so if I flip 1 upside down and change the sign, I get negative 1. There's our normal line. Yes, of course you can tidy this up. You really can. You should get y equals negative x for the normal line. But you don't have to. You can just stop at those points. All right. Now, we have this powerful tool for finding the slope at a point, or finding the slope, a slope machine, f prime of x, that would tell me the slope at any point I chose to plug into it. But not all curves have tangent lines at all points. So, this function, sorry, can't find the slope at that point. This function, I can't find the slope at that point. Now, what is it that is prohibiting me from finding the slopes at these points? Well, let's go back to this limit definition of the derivative for a minute. We said that the general derivative was the limit as h heads to 0 of f of x plus h minus f of x all over h, yeah? And guess what? The derivative is a limit. And in order for this limit to exist, I need to know that that the limit exists from both sides of 0. I think this is easier to show this way. Let's use this other limit definition of the derivative. It'll be a little easier on your brain. F of x minus f of a over x minus a. So in order for this limit to exist, we need to know that the limit as x approaches a from the positive side of f of x minus f of a over x minus a equals the limit as x approaches a from the negative side of f of x minus f of a over x minus a. So these are called one-sided derivatives. Because I'm coming in only from one side. I'm looking at the slope from one perspective. So let's go back to these pictures. We have this one. And that's y equals absolute x plus 4. Yeah? There's our minus 4. There's 0, 4. And this point over here, because of symmetry, is negative 8 to 4. All right, so now let's ask the question, because I claim that I can't find f prime of 4. F prime of negative 4 does not exist. Why do I think that derivative does not exist? Well, let's look at the slopes on either side of this point, right? As I approach negative 4 from the positive side, that's as I come in from this direction, what's the slope of this line that goes over 4 and up 4? Positive 1. Well, what's the slope of this line as I come in to negative 4 from the negative side? Well, I'm going down 4 and over 4. Does the slope from the left equal the slope from the right? Because that's what this says. This says find the slope coming from the right, find the slope coming from the left. If those things are equal, then, and only then, can we say the limit as x approaches a of f of x minus f of a over x minus a would exist. The only way this can exist is if these two produce equal things. We said that when we started this discussion of limits at the beginning of chapter 2. This limit definition of the derivative fails to exist if the limits from both sides aren't equal to each other. And that's true there. So this is going to take us in the direction of differentiability, i.e., can we take the derivative, or does the derivative exist at every point? Well, so I actually want to explore this a little bit more before we quite get that hard. Okay, I want to start with asking this question. If f of x equals 2x squared for x values less than or equal to 1 and 2x for x is greater than 1, how do I do this? Oh, you don't know what I want you to do. I want you to find f prime of 1. Find f prime of 1. And this is less than or equal to, and this is greater than. Okay, so in order to find f prime of 1, I'm thinking about the limit as x approaches 1 of f of x minus f of 1 over x minus 1. The problem is that my f of x is a piecewise function. And so really what I want to do is I want to confirm first that this exists, approaching 1 from the negative side, and x approaches 1 from the positive side. And if these two are the same, then no problem. I can find the slope at that point. Okay, so let's start with this one. As x approaches 1 from the negative side, that means values that are less than 1. This is my f of x. So I'm going to have 2x squared minus, what's f of 1? That's going to be 2 over x minus 1. And we're doing here the limit as x approaches 1 from the negative side. Well, if I pull out a 2, no, I'm not going to have enough space. So the limit as x approaches 1 from the negative of 2x squared minus 2 over x minus 1. If I try and plugging in the 1 now, I get 0 over 0. So I know by now that I should do some algebraic manipulation here. I take out the 2 and I see x squared minus 1, and so that's going to factor over x minus 1. And so now I've got the limit as x approaches 1 from the negative direction to x plus 1. And now I can do my direct substitution. I can plug this 1 in. By the way, it's not negative 1 I'm plugging in. It's 1 from the negative side. So when I plug in 1 here, I get 1 plus 1 is 2 times 2 is 4. So I know the slope on this part of f of x coming in from the negative side, coming in for x values below, is going to be positive 4. Okay? So the limit as x approaches 1 from the negative of f of x minus f of 1 over x minus 1 is 4. Well, now we need to repeat this process with the other direction. Now we want to say the limit as x approaches 1 from the positive side of f of x minus f of 1 over x minus 1. Now, conveniently, f of 1 is still evaluated over here because it says equal to 1. This is not where I plug a 1 in. I plug the 1 in over here. Not that it matters in this problem, but it definitely matters in other problems. 1 from the positive. F of x is 2x minus f of 1, so I plug my 1 in here, 2 over x minus 1. And if I try and do direct substitution, I get 0 over 0. So I'm going to take this a little further, and I'm going to say the limit as x approaches 1 from the positive of 2x minus 1 over x minus 1. Cancel, cancel, and so I get 2. So what I've learned is that because the limit as x approaches 1 from the negative side of f of x minus f of 1 over x minus 1 equals 4, and the limit as x approaches 1 from the positive side of f of x minus f of 1 over x minus 1 is 2, because these limits are not equal to each other, the limit as x approaches 1 of f of x minus f of 1 over x minus 1 does not exist. Okay? Because the limits of the slopes were not the same. Because the limit from the left and the right side were not the same, the limit at that point will not exist. Now, we could say this in a tidier way, I think. Let me see if we can use a tidier way. F prime of 1 does not exist because the limit as x approaches 1 of f from the positive of f prime does not equal the limit as x approaches 1 from the negative side of f prime, right? That's what we did. We said, okay, the slope from the right-hand side was 2, and the slope from the left-hand side was 4. So this notation is a little less cumbersome than the limit as x approaches 1 from the positive of f of x minus f of 1 over x minus 1. And over here does not equal the limit as x approaches 1 of f of x minus f of 1 all over x minus 1, but we have to make sure that this gets a minus. That's, instead of writing all this, we can simply say this. Okay? The limit of the slopes is not the same from both sides of x equals 1. And now, let's take a quick look at this graphically. Okay, so our function looked like 2x squared until I get to 1, 2. And what's the other piece? Y equals 2x. And so y equals 2x, y equals 2x squared. And what I see here is the slope from this side, the limit as x heads to 1 from the negative side of f prime of x. This slope here is 4, whereas over here, the limit as x approaches 1 from the positive side of f prime of x, that limit is equal to 2. That slope is 2. Gosh, we didn't even have to do the limit definition of the derivative. We see the slope right there. And because the limit of the slopes as we approach 1 from both sides, because the limit of the slopes, not the limit of the function, the limit of the slopes, because the limit of the slopes aren't the same from both sides of x equals 1, we know we can't take a derivative there. Now, I will say No, I won't even say that. I'm going to come back later and say that. Okay, so no derivative at 1. All right, let's go further. How about this situation? What if f of x were equal to x squared plus 1 for x values less than or equal to 1, or 2x for x values greater than 1? Are you ready to do it on your own, or do you need me to do one more? I'll do one more. I'm not shy. Okay, so in order for f prime of 1 to exist, we know that f prime of 1 could be written as the limit as x approaches 1 of f of x minus f of 1 over x minus 1. But in order for this limit to exist, the limits from both sides have to be the same. So the limit as x approaches 1 from the negative side, f of x minus f of 1 over x minus 1, should equal the limit as x approaches 1 from the positive side of f of x minus f of 1 over x minus 1. All right, so let's go about filling this stuff in. F of x from the left is this, x squared plus 1, f of 1. 1 squared is 1 plus 1 is 2. So minus 2 over x minus 1. Don't leave out the limit notation. Now, here I'm going to have x squared minus 1 over x minus 1, and we know that that's the limit as x approaches 1 from the negative of x minus 1 times x plus 1 all over x minus 1. These cancel. I can plug my 1 in, and I've got 1 plus 1, or 2. So we know that this limit equals 2. But what about the other side? What about coming from the positive side? Well, what do we know? We know that f of x is 2x, f of 1 is 2. Don't forget the limit notation. And then, if I factor out a 2, I'll be able to cancel the x minus 1's. And so we'll have limit as x approaches 1 of 2, x minus 1 over x minus 1, and we get 2. So I know the slope over here is 2. So is it true that the limit of the slopes from each side of this function are the same? Yes. And because the limit of the slopes from both sides of x equal 1 are the same on this function, we know that this limit at 1 exists and is equal to 2. Because these were equal to each other and they were both 2. And both of them were finding the slopes. We're finding the slopes on opposite sides of x equals 1. So yes, f prime of 1 does exist, and f prime of 1 is equal to 2. Now let's take another quick look at the graph here. So now I'm looking at y equals x squared plus 1. That's this, shifted up 1. So I have 1, 2 on this graph. And then I have y equals 2x for x is bigger than 1. And so that's this one, y equals 2x. And there's x equals 1. And what we're saying is, at this point, the slopes are approaching 2, the slopes are approaching 2. Since the slopes are approaching the same thing, I can take the derivative at that point. Okay? All right. What I don't want to hear you say is, I can't take the derivative at x equals a because there's a point there or a corner there. Yeah, that's not going to be okay. Don't use that language, because if you start using that language instead of the limit language, when you see this problem on the AP exam, you're going to completely blow it. You're just going to stare at it and say, I don't know how I'll prove that. So instead, let's go from, hey, if you want to say that the slope exists at a point, that's the limit as x approaches a of f of x minus f of a over x minus a. And in order for this limit to exist, we need to know that the limit as x approaches a from the positive side equals the limit as x approaches a from the negative side. So if these are equal to each other, then this is the slope. Then whatever slopes we got here, because they're equal to each other, will be this slope, and that's going to be the slope of f at a. All right. All right. Well, it's your turn now. I did 2. You've got to do 1 now. So f of x equals x squared for x less than or equal to 1 to x for x greater than 1. All right, please find f prime of 1. Pause the video. Come back when you have an answer. Okay, welcome back. So f prime of 1 will only exist if the limit as x approaches 1 of f of x minus f of 1 over x minus 1 exists. And in order for that to exist, I need the limit as x approaches 1 from the negative side of x squared minus f of 1 is 1 over x minus 1 is equal to the limit as x approaches 1 from the positive side of f of x is 2x minus f of 1. F of 1 is still found by plugging in over here, not here, here. This is equal to 1. So I get minus 1, because 1 squared is 1, over x minus 1. Okay, well here I can't do my direct substitution yet because I would get 0 over 0. But I can say the limit as x heads to 1 from the negative of x minus 1, x plus 1 over x minus 1. These would cancel, and now I can plug in my 1 and get 2. But what happens over here? If I plug in my 1, I have 2 minus 1 equals 1, and uh-oh, what, no, that's 0. That's undefined. Well, that's really unfortunate. I thought I knew that the slope over here was 2. What am I missing? You know, the only way I'm going to get 2 is if f of 1 is 2. Because then I'd have the limit as x approaches 1 from the positive of x minus 1 over x minus 1, and these cancel, leaving me 2. But, oh, I know what's wrong with that. Okay, so when I do this, the limit of the slopes over here was 2, because I did f of x minus f of 1 over x minus 1. I factored and canceled and plugged a 1 in and got 2. So I know the slope coming from the left is 2, and then the slope coming from the right, yeah, the slope coming from the right is definitely 2, because you know that slope is 2. So it has to be this way, and I take back what I said. To find f of 1 on this piece, I'm using this, not this. Okay. Now, this is not f prime of 1. I know, but I did all this work, Mr. Cooper. What do you mean this isn't f prime of 1? Well, so here's the thing. In order for f prime of 1 to exist, we need 2 things. We need the limit as x approaches 1 from the positive of f prime equals the limit as x approaches 1 from the negative of f prime. We need the limit of the slopes to be the same. And in this problem, that was true. But we need one other thing. And f must be continuous at x equals 1. And this is why we had to learn about continuity. Because if the function is not continuous, there can't be a slope there. Okay, and let's think about what we're looking at. Remember our f of x? Our f of x was defined as x squared for x less than or equal to 1, and 2x for x greater than 1. So let's take a look at the graph. What's that ordered pair? Plug in a 1, I get 1. 1, 1, 1. Now, this is the line y equals 2x. If I plug a 1 in here, 1 times 2 is 2. So here's the interesting thing. While the slope from this side is 2, and the slope as we approach 1 from the left side is 2, even though the limit of the slopes is the same, I can't find the derivative at 1 because this function isn't continuous. Now, I don't think you see anything like this on this test, but it is on the next test. This stuff for sure shows up on the Chapter 3 test. I think on the Chapter 2 test, it's just using the limit definition of the derivative, not talking about does the derivative exist at a point. But I wanted to practice using the limit definition of the derivative a bunch, and so that made an easy way to do it. Okay, so I've got 2 more thoughts for us. Okay, next. Find f prime of 1 given f of x equals square root of x. And I don't care how you do it. Okay, find f prime of 1 given this f of x. And when I say I don't care how you do it, what I mean is I don't care which limit definition of the derivative you use. Okay, you have to use the limit definition of the derivative. Though it's true on the calculator portion of our test, I'd expect you to be able to find f prime of 1 using your calculator. So we might want to review that. Okay, go to pause the video, come back when you're done. So f prime of 1 equals the limit as x approaches 1 of square root of x minus square root of 1 is 1 over x minus 1. And if I plug in the 1's, I get 0 over 0. So I know this needs to be rewritten, but I don't know how. So I'm scared, and I find f prime of 1 by doing the limit as h heads to 0 of square root of x plus h minus square root of x. Oh, this is 1. This is 1 over h. Well, I know that's 1, but I don't know what the hell to do with that. And I know if I plug in h equals 0, I get square root of 1 minus square root of 1, which is 0 over 0, and I'm kind of screwed. What if I try finding the general derivative, the limit as h heads to 0, square root of x plus h minus square root of x all over h? And I'm in the same sad place. So how am I supposed to evaluate this? Well, one of the things I love about this class is how this class ties together so many things we made you learn. The answer whenever I have to use the limit definition of the derivative on a square root function is I need to multiply top and bottom by the conjugate. That's the only way I have to deal with these radical problems. So I'm going to multiply by square root of x plus 1 over square root of x plus 1. Now I know that we normally rationalize denominators, but here we don't want the radical up top. We're rationalizing the numerator. Okay? In fact, I don't think we ever rationalize denominators in this class, but we definitely, in this situation, need to rationalize the numerator. So where does that take me? The limit as x approaches 1 of this times this, minus this times this, plus this times this, minus this times this, over x minus 1 times square root of x plus 1. Well, the middle terms cancel, and now what am I left with on the top? It's the limit as x heads to 1 of x minus 1 over x minus 1 times square root of x plus 1. And then I can cancel these and just have this, and look, I can do my direct substitution now. So that's the slope on this graph at that point. If I think about that graph of square root of x, at the point x equals 1, what I'm saying is the slope here is 1/2. Now, by the way, I know that many of you are probably saying, okay, this is a lot of work. Why do I care about the slope at a point? Well, I want to say two things. Yes, this is a lot of work, but starting in Chapter 3, I'm going to give you the derivative shortcuts so you don't have to use the limit definitions of the derivative. You'll use them on the Chapter 2 test, the Chapter 3 test. They might show up on the semester final, but then you won't need them really until the AP exam. Okay? Okay, so we'll have shortcuts. The second thing I want to say is, oh, it went away. Oh well, maybe it'll come back. But yeah, square root, oof, definitely practice that. Oh, why is it that I need to know that slope? Right. And that's what Chapter 5 is all about. Chapter 5 is all about all the applications of the derivative, all the different ways that we need or we can use the slope at a point. And that's pretty cool because that's our biggest chapter. I used to give it in 2 separate tests. In fact, we have 2 separate tests this year too. It's such a big chapter because there's so many things you can do with the derivative that we will in fact do them. Now, I went through that last problem using one limit definition of the derivative. But if you had said the limit as x approaches 1 of square root of 1 plus h minus square root of 1 over h, you would still multiply top and bottom by the conjugate. In fact, I think I want to simplify that. Plus h plus 1. Okay? And so when I FOIL, I end up with the limit as x head, no, h heads to 0. H heads to 0. H heads to 0 of 1 plus h minus square root of 1 plus h plus square root of 1 plus h minus 1 over h times square root of 1 plus h plus 1. Okay, so what do I see? I see these cancel. I see these cancel. Oh, I see these cancel. And so I'm left with the limit as h heads to 0 of 1 over square root of 1 plus h plus 1. If I plug in h equals 0, I now have 1 plus 1 on the bottom, or 1 over 2. I can get that same f prime of 1 regardless of which limit definition of the derivative I use. But in all of these ones where f of x is a radical, I'm going to need to multiply top and bottom by the conjugate. Okay, the last thing I want to ask you about is, what is the average rate of change in the area of a circle with respect to radius on 1 to 3. Okay, so in this problem, you're expected to be able to bring the equation for the area of a circle. And if you don't know the equation for the area of the circle, open up your notebook to the place where it says formulas I'm supposed to remember because College Board isn't going to remind me. Write down area equals pi r squared. Okay, that's my area formula. And what am I looking for? I'm looking for average rate of change. And so I know that's going to be a of 3 minus a of 1 over 3 minus 1. Well, a of 3 is 9 pi. A of 1 is 1 pi over 3 minus 1 is 2. So we get 8 pi over 2, or 4 pi. 4 pi is the average rate of change in area as radius goes from 1 to 3. Okay? All right. In fact, if we had some units here, so let's say radius is in meters, okay? And then area is meters squared. So what am I saying here? I'm saying the area is changing. The things on top are square meters, for every, what are these units down here? These are radius units. They're in meters for every meter. Now, this would be a place where it wouldn't make absolutely any sense to me whatsoever if you had this rate of change called 4 pi meters squared for every meter. What does that mean? On this interval, for every 1 meter change in radius, the area is going up by 4 pi square meters. Okay, let's say that again. For every 1 meter increase in radius, area increases by 4 pi meters squared. Okay? And that's really important because what a lot of students want to do with this number, 4 pi meters squared over 1 meter, is they want to do that. And they want to claim the answer to be 4 pi meters. Meters is a linear measure. Area is this. If you say this, you're not talking about this. So I think I think canceling these units was not such a good idea. Would not do that. Likewise, when we talk about acceleration, and if I want average acceleration, I'm thinking about v of b minus v of a over b minus a. Now the units up here are going to be something like feet per second. And the units down here are going to be seconds. And that's the way I like to think of it. But many students say feet per second squared. I don't know what the hell a square second is. But over here, when I see feet per second this way, then what I know is if I have 4 pi over 1, I'm saying for every increase in 1 second, the velocity is changing by 4 pi feet per second. I can actually make sense of this in the real world. For each additional second, the average acceleration, yes, the velocity feet per second is going up by 4 pi feet per second. Please, I know I won't mark it wrong, but students who do this don't understand this, and therefore they can't explain this when they use this notation. So please don't use this notation. Please use this notation. I know you love talking about feet per second squared, but nobody knows what the hell it is. Okay, the last thing I want to do is, what's a prime of 2? I want to know a prime of 2. That's the instantaneous rate of change in area with respect to radius. Okay? A prime of 2. So we know that a equals pi r squared. And I want to find a prime of 2. Guess what? This is your last opportunity in this video to use a limit definition of the derivative. Okay? I was thinking about using the limit as r heads to 2 of a of r minus a of 2 over r minus 2. But you could use one of the others. In fact, maybe since I was going to use that one, I shouldn't. Maybe I'm going to say a prime of 2 is the limit as h heads to 0 of, I need f of a plus h, so that's pi a plus h squared minus f of a, which is pi a squared. Oh, my a is 2. Let's put the 2. All over h. Okay, so what am I going to do to figure this out? Well, I can say that this is the limit as h heads to 0 of pi 4 plus 4h plus h squared minus 4 pi all over h. I have to distribute here, so the limit as h heads to 0 of 4 pi plus 4 pi h plus pi h squared minus 4 pi all over h. And then, are there any like terms to combine? Sure there are. The limit as h heads to 0. Oh look, I can't plug in a 0 or I'd get 0 over 0. I better factor out that h. 4 pi plus h. 4 pi h, yes. Yes. Oh, there's a pi missing. There we go. Over h. And then I cancel these. Now I do my direct substitution, and I get 4 pi plus 0, or 4 pi. That's f prime, that's a prime of 2. And if my units are, these are areas, and these are radii. So my rate of change, that's the instantaneous rate of change when radius is 2. So a prime of 2 equals 4 pi, and I want to say meters squared per meter, because these are areas and this is radius. All right, that's a lot of stuff. Kind of want to do it the first way I wanted to do it, just to see. The limit as r approaches 2 of a of r minus a of 2 over r minus 2. So that's going to be the limit as r approaches 2 of pi r squared minus 4 pi over r minus 2. Ooh. Okay, so then that's the limit as r approaches 2 of a lot of pi r squared minus 4 over r minus 2. Oh, well, that's not so bad, because that's the limit as r approaches 2 of pi r minus 2 r plus 2 over r minus 2. These cancel. Now I can do direct substitution. I get pi 2 plus 2, or 4 pi. And that's going to be a prime of 2. All right, get comfortable with those limit definitions of the derivative. Remember, tonight's homework is assignment 33, and I can't wait to see how it goes for you. All right, take care, everyone.